Okay, in this video, we're going to be doing Calc AB problem set number 106. Let's take a look. Oh, well, the problems and a playlist are in the description below. Let's take a look at the problems. Number one, we want to evaluate the integral of 3x over the square root of 4 minus 12x squared. And then we want to integrate 1 over the square root of 4 minus 12x squared. So like they're similar problems, but slightly different, and that's why we're doing them together. So for the first one, or really for both of them, my first thought would be to make u equal 4 minus 12x squared. And then that would mean du is negative 24 x dx. So I'm going to write negative 1 over 24 du is x dx. So in this case, because I have a 3, I'm just going to like pull the 3 out of the integral. And then I'm going to replace x dx with negative 1 over 24, which I'm going to pull out. Integral of, and then it'll be du over the square root of u. I think it's easier, so I mean 3 times negative 1 over 24 is negative 1/8. I'm going to rewrite it with a negative rational exponent instead of using a radical notation, because I think that's always easier. Plus 1 times the reciprocal, so that's going to give me 1/2 is the exponent, times 2. Negative 1/8 times 2 is negative 1/4. So u to the 1/2, and then plus c. And then we go back and we replace u with 4 minus 12x squared. So we get this. Okay. Now, the next one is really similar but different. So the issue is that we have a 1 here. We don't have any x's in the numerator, as opposed to this one where we had 3x. So now I'm dealing with 1 over the square root of something where u-substitution did not work. I immediately think of all the derivatives I know. One of them definitely has a radical in the denominator. This, I think, is arcsine. So if it's arcsine, the single most important thing, well, I mean, it's all important, but is to turn that 4 into a 1. So I'm going to factor 4 out of the radical, which is, well, I'm going to factor 4 out of everything in the radical, and then the square root of 4 is 2, so I'm really taking 1/2 out. 1/2, the integral of 1 minus, now we have 3x squared. So we know that arcsine is 1 over the square root of 1 minus u squared. So I'm going to rewrite 3x squared as the quantity root 3 times x squared. I had a lot of trouble saying that. I don't know why. 1/2 the integral of 1 over 1 minus the quantity root 3 times x and all squared. So that we can do a u substitution. U is going to be root 3x, which means that 1 over root 3 du is equal to dx. We can do all of our substitutions now. So we get 1/2. The 1 over root 3 I'm going to pull out. And then the integral of, we got 1 over the square root of 1 minus u squared du. That's a perfect arcsine. So I'm going to write this as 1 over 2 root 3, and then arcsine of u plus c, and then u is the square root of 3 times x. So finally we get 1 over 2 root 3 arcsine of root 3x plus c. All right, next up, we want to evaluate the derivative of the integral from 3x to 5. So that's weird because the variable should be on top. So we'll deal with that in a second, of t squared over 1 plus t dt. All right, so what I'm going to do is I'm going to flip the bounds and change the sign. So I'm going to do negative integral from 5 to 3x of t squared 1 plus t dt. And this is a second fundamental theorem problem. So the derivative of an integral, we're going to take the upper bound, which is 3x. We replace every t that we see with 3x. So we get 3x, the quantity 3x squared, 1 plus the quantity 3x. And then we can just, multiply. Oh, and then chain rule, right? So substitute 3x for every t that we see, get that, then multiply by the derivative of 3x, so times 3. All right, and then multiply it out, negative 27x squared over 1 plus 3x. And that's as good as it's going to get. All right. Next up, I think this is the first area problem that we've done. Maybe, I'm not really sure. We want to find the area of the region enclosed by the curves. F of x equals negative x squared plus 2x, and g of x is x squared. So we can kind of sketch it. One of them is a parabola that opens up. One of them is a parabola that opens down. So that'll be easy to determine which one's on top and which one's on the bottom. F of x is definitely the top function. G of x is the bottom. Before we do that, we need to know where these things intersect. So we're going to solve f of x equals g of x. So negative x squared plus 2x is equal to x squared. Move everything to one side. I'm actually going to move everything to the right, but then I'm going to like flip it. So we end up with 2x squared minus 2x equals 0. I moved everything to the right. That's what happened. This factors 2x and x minus 1. So we know that x is 0 or x is 1. All right, so now our area is going to be the integral from 0 to 1. Those are the bounds. Top take away bottom. So we need to identify the top curve and the bottom curve. So we're really just doing f of x minus g of x. If this was calculator, I would just write f of x minus g of x and then get the answer. But this isn't calculator, so f of x is negative x squared plus 2x minus g of x is x squared. So that's top take away bottom dx. And now it's just like a normal thing. So, collect like terms, and then we're going to reverse the power rule, negative 2/3 x cubed plus x squared, and we're going from 0 to 1. We're going to plug in 1, and we get negative 2/3 plus 1 minus, when you plug in 0, you just get 0, but I still think it's good to write that. And so we have 1 minus 2/3 is 1/3. Okay, so that's the area of that little region there. We're going to do 2 more area problems. You really want to get good at these like as soon as you can, so that's why we're throwing these up here. F of x is negative x squared, so that opens down, and then g of x is 4x squared plus 10x. That opens up, so it's like easy-ish to figure out what the graph looks like. It doesn't need to be perfect. You just need to really figure out which curve is on the top and the bottom. We also need the intersection points, so f of x equals g of x. Negative x squared is 4x squared plus 10x. Again, I'm moving everything to the right-hand side, but I'm going to write it on the left-hand side. That's how I do it. We can factor 5x out, and we get 5x quantity x plus 2. The zeros of this are x equals 0, x equals negative 2. So to find the area, again, we need to know the top and the bottom. So we're integrating from negative 2 to 0. The top curve is definitely f of x, and the bottom curve is definitely g of x. I hope that doesn't keep happening with every problem. I'm going to try to think about that for future problem sets. All right, so top curve is f of x, so negative x squared minus, I think it's important to put parentheses around these things. Not so much the top curve, but the bottom curve, because you have to distribute the negative all the way through. So I like to make sure that I've put parentheses so that I'm not going to screw that up. Collect like terms, so we get negative 2 to 0, negative 5x squared minus 10x. Reverse some power rule, negative 5/3 x cubed minus 5x squared. And then we're going from negative 2 to 0. And so when you plug in 0, you get 0. So it's 0 minus the quantity. When you plug in negative 2, you get negative 5 times negative 8, which is 40 over 3, and then minus 20. So we get that, and then so 40 over 3 minus 60 over 3 is negative 20 over 3, but it's minus negative 20 over 3. So we finally get 20 over 3, and that's our answer to that. All right, one more. We got f of x is negative 3x squared plus 2, and g of x is negative 3x plus 2. I'm going to think about it for next time. So f of x is a quadratic that opens down. G of x is a linear function. Our graph looks basically like this. Again, it doesn't need to be perfect, just needs to be good enough. Again, f of x is on top. That does not happen 100% of the time, just when the person writing the problems didn't think about it enough, I guess. So we need the intersections. F of x equals g of x. So negative 3x squared plus 2 equals negative 3x plus 2. Move everything to one side. It doesn't matter. I'm going to move everything to the left this time. So negative 3x squared plus 3x equals 0. You can factor a negative 3x out. The zeros of this are 0 and 1. So our area will be the integral from 0 to 1. Top curve, which we said is f of x, minus the bottom curve, which is the quantity negative 3x plus 2. So put parentheses around it so you don't screw up there. And then collect like terms. Reverse the power rule. So we're going to get negative x cubed plus 3/2 x squared. And we are going from 0 to 1. So we take 1 and we plug it in. That's going to give us negative 1 plus 3/2 minus, plug 0 in, you just get 0. So negative 1 plus 1.5 is 0.5. So we get 1/2 as our answer. That's the whole problem set. So that's a couple of area problems. Those are pretty common. I hope this was helpful, and good luck.